Hi, Year 11s. This is Mr. Lim again, and this is our third video on calculations with mass and moles. So let's get started. All right, we're going to be learning about molar mass and how to use molar mass and moles to solve for stuff. All right, so mass of atoms. The mass of different atoms is different due to the differences in numbers of protons and neutrons. Okay, so effectively mass atoms weigh differently because of the number of protons and neutrons, because the electrons don't weigh that much. So the mass then of different molecules and ions are also different because, molecules are made up of different components, and therefore their weights will be different depending on what components they're made out of. Right, so their masses are directly linked to the number of protons and neutrons. So the RAM, the relative atomic mass of these atoms or molecules or ions, can be used to work out the relative mass of these substances, right, the relative mass. So how much heavier is 100 molecules of O3 compared to O2? Let's have a think of it. Right, well, it should be, 150% heavier because, oops, that's not what I want. 150% heavier because there are 3 lots of 16 in O3 versus 2 lots of 16 in O2. Right, so that's going to be 1.5 times as heavy. All right, so that makes sense because O3 and O2 of O3 is 1.5 times bigger than it. All right, so what about carbon dioxide and oxygen? Well, carbon dioxide has a relative atomic mass of 44.01, right, grams per mole. That's its molar mass. And oxygen gas only has one of 32 grams per mole, right? And so therefore it's going to be roughly, 25% bigger, all right, roughly. So let's keep moving. Molar mass. So scientists decided that the RAM then in grams would be a good way to group atoms, right? So because then the information would be readily available because, your RAMs are easily to be described to other people and then easily communicated and calculated. All right, so if you can calculate the RAM of a substance, then weigh out that much of a substance in grams, you have one group, right? So we're just saying, let's just take that RAM value, everyone can work it out, so therefore that's going to be one group of stuff, right? That group is 1 mole, that's why it's such a random number. It's known as the molar mass, okay? So the mass of its RAM, right? So 1 mole of sugar weighs how much then? Right, so then 1 mole of sugar is equal to its RAM, okay? So therefore, this is going to be 6 times 12.01. This is going to be equal to 12 times 1.008. And this is going to be equal to 6 times 16.00. And the value for that is going to be something, all right? 12.01 times 6 plus 12 times 1.008 plus 6 times 16, and make sure you're using brackets for these calculations, and it's 180.156 grams in that mole, or to make up that mole. All right, 2.5 moles of water weighs how much? Okay, so let's have a think. Water is 2 times 1.008, and oxygen is 16 times 1, right, which is equal to 18.016, right? Then 2.5 moles of that would be 2.5 times that. So 18.016 times 2.5, right, would be equal to 2.5 moles of that would be equal to 45.05 grams, right? Because I took that 18.016 value and times it by 2.5 to get the mass of 2.5 moles of that substance, because the 18.016 is how much 1 mole weighs, right? So let's move on. So then, this is the formula that you need to remember, okay? Where N is equal to little m over big M, where N is the number of moles, M is the mass in grams, and big M is the molar mass, okay? Which is the one that you get from the data sheet. Okay, it can be arranged into the other 2 forms there, right? But that's nice. Let's move on. Come on. Here we go. All right. So how many moles of each of these substances exist in 6.43 grams of the substance? Okay, so we're generally going to get a mass in grams, and then we have to work out how many moles there are. All right, so this is a very typical calculation. So sodium chloride, the big M, or the molar mass of sodium chloride, and you're going to start seeing me use these this formatting where I show what I'm solving for and the chemical that I'm solving for in brackets. This is going to be a very common way to show stuff because at least it just shows your working, which is definitely necessary. Okay, so that's going to be 22.99 plus 35.45, which gives me some value, 58.44 grams per mole. And then I want to find out how many moles. So N of NaCl is equal to little m over big M, which will be equal to 6.43 over 58.44, which is equal to 6.43 divided by my answer, 0.110 mole. Okay, and be good to save it's always good to save the molar masses in your calculation because then at least you can show and get exact values. Kind of important. All right. So for silver nitrate, so again, the molar mass of silver nitrate, AgNO3, will be equal to silver, which is 107.9, plus nitrogen, 14.01, plus oxygen, which would be 3 times 16. Okay, all the parts of that. Right, so 107.9 plus 14.01 plus 3 times 16 is equal to 169.91 grams per mole. And I'll save that as B. Okay, then I can work out the number of moles of NaCl, right, which will be equal to, little m over big M, which would be 6.43 over that value B, which would be equal to 6.43 divided by B, 0.03738 moles. Okay, all right. You have a go at doing these chloride ions. Pause the video and see, here we go. All right, but just remember, right, read the question. How many moles of chloride ions? Right, so you'll have to think about these formulas here. Actually, maybe let's just go through it together. The molar mass of lithium chloride, and that's the formula for lithium chloride. Lithium chloride is 6.94 plus 35.45, which is equal to 6.94 times plus 35.45, 42.39 grams per mole, which we'll save as C. Right, and then the number of moles of LiCl will be equal to the mass, which is 4.3 over C, which will be equal to 4.3 divided by C, 0.101 mole. Okay, however, this next one, the molar mass of iron 2 chloride. Iron 2 chloride would be this. 2 chlorines to match with the 2 ions there. Right? And so then we just go do iron, which is 55.85 plus 2 times 35.45, which would be equal to 126.75. Get the number of moles of FeCl2. Okay, so this is the number of moles of the whole formula units, which is 4.3 over, and I saved that as D, didn't I? Okay, D, which would be equal to 0.0339 moles. However, that's the number of moles of FeCl2. I've been asked for the number of moles of chloride ions, right? So the number of moles of Cl minus ions is equal to the number of moles of FeCl2 times 2, because there are 2 Cl's in that one there, right? So I times that by 2, and I get 0.0679 moles. Okay, in this first one, you should also just show that you're solving for the number of moles of chloride ions, which will just happen to be the number of moles of lithium chloride ions times 1 on 1, whoops, times 1 on 1, which will just be equal to the same value, 0.101 moles. Okay, but you got to read the question, see if there's any other trick questions part of it. All right, let's move on. What is the mass of 1.8 moles of the following substances? So this is using the molar mass and the number of moles to work out the mass. So therefore, calcium carbonate, again, molar mass of calcium carbonate, just to make sure we know what we're doing. Calcium carbonate is 40.08 plus 12.01 plus 3 times 16, which will be equal to, now you don't have to show all of that. If you can do that in your head or on your calculator without writing it down, that's fine. But you should at least show that you did solve it somehow. Right, this is 100.09 grams per mole, which we're going to store as A again. Right, and then I want to find out the mass of calcium carbonate, which is equal to N times M. So therefore 1.84 times A, which will be equal to 184.17 mole. All right, the next one is I got to get the molar mass of lead 4 sulfate. So lead 4 sulfate would look like this. And the molar mass of that would be the Pb, which is 207.2, plus the S, and there's 2 of them, 32.06, right, times 2 of them, because I've got the coefficient here, which means that everything inside the bracket is expanded, all right? And then I've got 8 times 16, okay, grams per mole. Let's see what that is. So 207.2 plus 32.06 plus 2, no wait, that's times 2. Times 2. Yep, times 2. And then add finally the 8 times 16. Okay, which is equal to 399.32, all right, grams per mole, which will save as B. Okay, and then we've got the mass of PbSO4, which will be equal to, taking that number and multiplying it by 1.84, which is equal to 734.7 grams. Okay, right. Then it is found that 1.8 moles of a substance weighs 28.8756 grams. Is this substance one of those? Okay, so this is the opportunity for you to solve for big M. Big M of unknown is equal to M over N, okay, which means it's 28.8756 over, and we got to check all of these, so let's have a look. 28.8756 divided by 18.01, which is the molar mass of water, okay. The molar mass of water is 1.603. Okay, let's do that again. 28.8756 divided by 44.01, which is the molar mass of carbon dioxide, 0.656 mole. Okay, CH4, so that's 12.01 plus 4 times 1.008. Okay, so that molar mass is 16.042. We're going to store that under C. Right, and then we're going to times that by 1.8 to get you 28.88 moles. Okay, and then finally, actually no, that's the weight. This is not moles, these are all weights, these are all grams. Okay, and this is pretty close to the number, right? So you see here that this CH4 is very close to that number, but I wouldn't stop there anyway. I would also go and check the last one. So it's going to be the molar mass of NO2 is going to be 14.01 plus 2 times 16, which is equal to 46.01 times the 1.8 is equal to 82.82 grams. Okay, so which one is it? It's got to be C, because that's the one that's closest to the value. All right, and that's it. Next we'll go into harder calculations, so be prepared. Adios.